Welcome to the Rim Break Rodeo. We hope this video helps.
You start by verifying prerequisites and powering the device. Get the GPS module, a microcontroller, and a comms option like SIM or Wi-Fi. Once done, flash a basic firmware that reads NME or binary GNSS output and prints lat/long to serial so you can confirm fixes. Make sure to provision an API key for maps or a server endpoint. This prevents later integration delays. You're now ready to wire serial or I2C and move into data parsing. You'll implement parsing and a reliable data flow next. Use a tested NME or GNSS library to extract coordinates, timestamp, speed, and fix quality. Once parsed, normalize and buffer records to handle intermittent connectivity, then encode as JSON or a compact binary frame for efficiency. Make sure to add auth tokens and send via HTTPS or MQTT over TLS. If cellular, include exponential backoff and retry logic. This stage ensures accurate, secure delivery. You finish by persisting and visualizing. Write incoming points to a time-indexed database with geospatial indexing, then render on map tiles and add geofencing and alert rules. Once done, implement smoothing and outlier rejection so tracks look clean. Make sure to build diagnostics, log satellite count, HDOP, and battery voltage for root cause analysis. If things go wrong, check for no fix or poor HDOP first. Replace antenna. Verify sky view and confirm power stability before deeper debugging.
Thanks for watching. Consider subscribing if we helped you.